This is from 2018 AMC 12, problem 14. Now we have this equation with different bits 3x and 2x, and x is a positive real number, can be expressed p over q. We try to find p plus q. Try to solve this problem. One hint is that if you have different bases for the logarithm, it is useful to use change of base. So pay attention to number 4 and 8, which is power of 2. We're going to review some of the fundamentals, but feel free to skip to the solution if you already know the content. Logarithm is the inverse operation of exponentiation. That is, if you have b raised to x power equal to n, then x would be the logarithm base b of n. So notice that the base is always a positive number. Now the logarithm of n to the base b is the exponent to which b must be raised to obtain n. So in mathematical language would be this identity here. It's very useful. That's by the definition of the logarithm. For example, we say to the third power equal to 8, but what's 2's power would give 7. The answer would be log base 2 of 7. Right? This quantity is slightly smaller than 3. Some example of logarithm. By definition, what is the value of here? You know that 2 raised to third power is 8, so that's equal to 3. How about that? 10 raised to what power? Second power, so that's 2. How about this? 5 raised to third power, that would be 3. Right? So notice that the value could be a negative or fractional value. It depends on the base and the number being evaluated. For example, in this case, 2 raised to what power produce 0.5, negative 1. How about 10 raised to what power produce 0, 0, 1? That would be negative 2. And in this case, notice that 1 over 9 is 3 raised to negative 2's power. The answer is also negative 2. Okay? And other properties of this function, the log of the base equal to 1. And this by definition, earlier we know that. And here the logarithm of 1 equal to 0 because a to the 0's power is 1. It's also a useful property here. And some other property is that the product will become the sum of log. And the division will become the difference here, the minus here. And the power is going to be r times this. And another very useful fact is change of base. So this allows us to evaluate any logarithm with some known base. For example, if we have base 10 or base e, natural log. And let's go back to our original problem. As hinted earlier, it's useful to do change of base and also treat 4 and 8 as power of 2's. Now you can use the basic property of logarithm, that is, for the exponent here, you can take the in front of it, become multiplication of the logarithm. So that would become 2 and 3 here for the coefficient here. And of course, you can cancel log 2, cross product. Now here, you're going to use the property of log that the multiplication becomes addition of 2 logs, right? So let's do that. Now this linear equation in terms of log x, right? You can solve for log x. You can simplify this. Here, when you use the reverse of the previous rule, that is 2 log 2 becomes log 2 to the second power, log 4, and log 3 becomes log 3 to the raised to the third power. So you're going to move this to the exponent here. Log 4 minus log 27, that's a division rule here. Okay, so x would be 4 over 27. P over q, 4 over 27, the summation is going to be 31. That's the answer. So in summary, we use change of base, we take advantage of 4 and 8 as power of 2, and then we solve an equation for log x, and then you find the value of x. We have a series of videos on logarithm and in AMC 12 and other exams. Hope you enjoyed the video. Please like, share, and subscribe to the channel.